Hello all, welcome back. In this unit, we will learn about a critical skill for data analysis, understanding the difference between correlation and causation. This causes more bad decisions than almost any other error in data analysis. Let's look at an example to understand this. In India, ice cream sales and drowning deaths both increase during summer months. If you look at the data, they rise and fall together almost perfectly. Spot the difference. Does this mean ice cream causes drowning? Of course not. This is correlation without causation. In other words, the two things happen around the same time, but one doesn't cause the other. Let's learn how to spot the difference between these two. Here's the key difference. Correlation means two things change together. When one goes up, the other goes up. Or when one goes down, the other goes down. They move in the same pattern. Causation means one thing directly causes the other to happen. With ice cream and drowning, there is a third factor causing both: hot weather. When it's hot, people buy more ice creams and more people go to swimming, which increases the risk to drowning. This hidden factor is called a confounding variable or a lurking variable. Understanding this difference is crucial when Aisha analyzes the Odisha flood dataset. Let me show you why. Now, open your database and look at Aisha's Odisha flood tender data. Notice that tenders with higher awarded values tend to have longer project durations. Expensive projects take more weeks to complete. There is a clear correlation. But does spending more money cause projects to take longer? Or do longer projects naturally cost more because of extended labor and materials? Or is there a third factor? Maybe larger, more complex projects both cost more and take longer. If district collectors think spending more causes delays, they might try to reduce budgets to speed things up. That would be a disaster. You would have underfunded projects that still take time but aren't completed properly. The real causation is due to project complexity, which causes both higher costs and long durations. Districts that submit more tenders tend to receive more funding. More tenders correlates with more money. So, should other districts be told to just submit more tenders to get more funding? Not so fast. Let's think about causation. Does submitting tender cause funding to appear? No. The funding has to be available first. The real causation likely works like this. Districts with better administrative capacity can identify projects, prepare documentation, and submit quality tenders. That same capacity helps them utilize funding effectively. So, administrative capacity causes both more tenders submission and more funding approval. If a district with weak capacity tries to submit many tenders, they will be poorly prepared and likely get rejected. Seeing correlation and assuming causation leads to policies that don't work. So how do you tell correlation from causation? Use this 3-question test. Question 1. Is there a plausible mechanism? Can you explain how one would cause the other? If higher budgets cause delays, what's the mechanism? There is no money and it doesn't create delays. Question 2. What's the time order? Does the supposed cause happen before the effect? If complexity causes both costs and duration, does complexity get determined first? Yes, project scope is defined before budgeting and scheduling. Question 3. Are there alternative explanations? Could a third variable be the real cause? Always look for confounding variables. With the ice cream and drowning example, the alternative explanation was hot weather. That makes much more sense than a direct causal link. Apply this test to any correlation you find in data before making decisions. Here's what this means for your data analysis work. When you find patterns in data, do not jump to conclusion, but always ask, 1. Is this just correlation or is there a real causation? Don't assume that things happening together means one causes the other. 2. Look for confounding variables. Think about mechanisms and time order. Test alternative explanations. This is especially important when you present findings to decision makers like the district collectors. But if Aisha says districts which have strong administrative capacity, both in terms of submitting quality tenders and utilizing funding correctly, capacity building is the key. That's actionable insight based on understanding true causation. Data literacy means not just finding patterns, but understanding what does patterns really mean. I hope you enjoyed learning about this.